When completing stoichiometry problems, we're going from mass of one to mass of the other. Looking at your little flow chart here, you're going to be starting here grams of something, and we want grams of another substance. So you're going to need to make 1, 2, 3 conversions. These 3 conversions. How do I know what I'm looking for and what I'm given? All right, so guys, how do I identify what substance A and what substance B? I'm going to pretty much tell you for our problems that we are doing, you're given a number here. All right, that's going to be substance A. So 0.52 grams of what? Just magnesium. So that's substance A. Now, because I'm starting with grams, I'm starting here. They want you to calculate the mass of something else. What is the mass of the other thing? It says mass of magnesium oxide. So you got to be able to identify the 2 pieces. Well, magnesium by itself, don't worry about the little subscript S here in parentheses. That's just telling you what state of matter it's in. It's a solid, gas. It's going to give us a solid. So you should know that that is magnesium, that is oxygen, and then this would have to therefore be magnesium oxide. So now I know what is A and what is B. 2 other things that I would do before I even start the problem. If I know I'm going from grams to grams, I need molar mass of both of those substances. So that is what we're going to need, and that's where your little periodic table comes into hand. All right, substance A is just magnesium. So that's super quick and easy. Magnesium is 24.31 grams. So I like to do it off to the left side. Mg. Why did I write that? 24.31. All right, that's grams per 1 mole. And then the other thing is MgO, magnesium oxide. Well, we already know that magnesium is your 24.31. There's only one of them, so we don't need to multiply that by anything. And then oxygen, periodic table, 16 grams per mole. Add that together. And we get an answer here of 40.31 grams per mole. Okay, why do we want those 2 things? Well, so we already have them here, and we don't have to waste time now. All right, so, okay, I understand I need molar mass. Cool, we've done that. Now, what the hell do I do? Very simple. Take what you're given and put it in the starting spot. So we're given 0.52 G of magnesium. So we're going to start it off like this. 0.52 G of magnesium. Now remember, I said we got to make all 3 conversions. So my first conversion is going to be 1 mole of substance A. Again, substance A is magnesium. So you're going to just write 1 mole of Mg. And it's going to go over the molar mass of substance A, again, which is magnesium. We have that off on the side. 24.31 grams of Mg. Why does it need to be like that? Because in order to move from one unit to the other, we have to cancel out of another. So that is why we have 1 mole on top and grams of magnesium on bottom. The next conversion, number moles of B over number moles of A. Where the hell do these little numbers come from? They come from the coefficients. So, what was substance B again? Magnesium oxide, which is the MgO. I'm going to leave real quick. Blank moles. MgO over blank moles of substance A, which is magnesium. And then where the heck do those 2 numbers come from? They come from the coefficients. All right, is there a coefficient in front of Mg? Yeah, it's 2. All right, this little 2 guy right there. And is there a coefficient in front of the MgO? Yes, that is also a 2. Now, finally, our third conversion. Well, why wouldn't we stop here? If we did, grams would cancel, grams of magnesium would cancel, and moles of magnesium cancel. So if you stopped here, The only unit that didn't get canceled out would be magnesium oxide. They didn't want that. They wanted mass of this. So that is why we need to make sure we have our third and final conversion, the molar mass of substance B divided by 1 mole. So we've already did off to the side the molar mass of substance B, which was the MgO. So we have to have the 40.31 grams of magnesium oxide over just 1 mole of that substance. Now we have moles of magnesium oxide that cancel, and the unit that we'd be left in would be grams of magnesium oxide, which is what we want. Okay, awesome. Now I got all this. What in the hell do I do? Well, what we do is you multiply everything on top and then divide by what's on bottom. So we got 0.52 times, we don't need to do anything with 1, so times 2 times 40.31. Nope, got to go back it up real quick. 40.31. Okay, that's going to give us a number. Do I need to write that down? No. Once you've done that, now you're going to divide by what's on bottom. So how I do this is I just divide individually. I go divide that by 24.31, hit equals, and then I divide again because there's a 2 on bottom. I'm going to divide that by 2. And do I need to do anything with the 1? No, you don't. So this would be your final answer, and I will say we can round this one to 2 decimals. So this would be 0.86, and the unit that you need, grams magnesium oxide. All right, so there's your fully completed process. Again, how do you run through it? The dude with the number, all right, pretty much 97% of the time is going to be substance A. You're given this much, all right? They want you to calculate how much of something else you're going to have. So that something else is B. And then if it was moles of B, you would stop here and you would only use those 2 conversions. If it was grams of substance B, well, you need to do that. All right, and again, it's going to depend when you read a problem. If you're given moles of substance A and they want grams of B, you use those 2. If you give moles of A and just want moles of B, you just use this conversion. All right, it's very straightforward. We just need a little bit of practice. Okay, we got a lot of things going on here. It says determine the mass of iron 3 hydroxide, which should precipitate when a solution containing 3 grams of iron 3 chloride reacts with an excess of sodium hydroxide. So they're like, wait a minute. I see iron 3 hydroxide, iron 3 chloride, and sodium hydroxide. Now I got 3 things. How do I know what's what? Well, due to the number is going to be substance A. So 3 grams of iron 3 chloride. That's A. How the hell do I know what's iron 3 chloride? That's iron 3 chloride. And what do they actually want? Determine the mass of iron 3 hydroxide. That is your substance B. So we need to determine, okay, who is what? Hydroxide is OH, so this is our substance B. Yep, because we're in grams of something and we want mass of something else, we are going to be going from grams to grams, so we're going to need the molar mass of these guys. I like to do that straight in the beginning. All right, get it out of the way. So that's what I'm going to do. So I'm going to start off over here, FeCl3. So I have iron, which is 55.85, plus chlorine, or chloride here, 35.45. How many chloride are there? 3. So you have to multiply just the chloride by 3, not the whole thing together. All right? Throw this into your calculator. We're going to spit out an answer here of 162.2 grams of iron 3 chloride. And substance B was iron 3 hydroxide. So with that, FeOH3. So iron, there's only one Fe, so that is your 55.85 plus. Now, zoom in for a second. When you have a number outside of the parentheses, it distributes inside. So there's one oxygen, there's one hydrogen. 3 times 1 is 3. So you're going to have 3 oxygen and 3 hydrogen. Hypothetically, if you saw something like this, PO4, 3, you would have 3 P's, and 3 times 4, you would have 12 oxygens. Just, I want you to keep that in mind. So we have to do oxygen, which was that 16, times 3, plus hydrogen, which is 1.01. And multiply that together. And this is going to kick out an answer of 106.88 grams of iron 3 hydroxide. So I have my substance A and substance B. Cool. So now I pretty much just go back to my chart. Going from grams of something to grams of another. So we need to go here to here. So you got to use all 3 conversions. So how do I go about it? First thing I'm going to do is take what I was given, that 3 grams, and put it into the starting spot. 3G of FeCl3. First conversion, 1 mole of that substance A. So in 1 mole of iron 3 chloride, we have the molar mass of that, which is our 162.2. Our next conversion, number of moles of B versus over number of moles of A. So what was substance B again? It was the iron 3 hydroxide. So we have there FeOH3, how many moles, and then moles of substance A, which was the iron 3 chloride. Do they even have coefficients in the balanced equation? There is no number out in front of them, so that means it's just a 1-to-1 ratio. Excellent. And then the last conversion would be the molar mass of substance B over 1 mole. So 1 mole of substance B, which is the iron 3 hydroxide. And the molar mass of that guy is 106.88 grams of FeOH3. Okay. Let's double check to make sure everything balances out or cancels out that we need. So grams of iron 3 chloride on top and bottom, good. Moles of iron 3 chloride on top and bottom, good. Moles of iron 3 hydroxide, top and bottom, good. So that would leave us in the desired unit of grams of iron 3 hydroxide. So in your calculator, multiply everything on top, divide by what's on bottom. 3 times, we don't need to do 1, times 106.88. Good, and then divide by this 162.2. It equals, divide by, we don't need to divide anything else because they're all ones on the bottom. So we are going to be left here with the final answer of, you could do 197.6, so the 8 would bump this up to a 7, bump this up. If we wanted to round it to just 2 decimals, it would be 1.98 grams of iron 3 hydroxide. All right, so it does give us 3 sig figs here, so that would leave us with rounding this to 3 numbers anyway. 3 sig figs, it works. And yeah, I mean, that's pretty much what you guys are going to go and do from there. So again, a lot of it's going to come down to properly identifying A and B. So before I let you guys start to work on this, okay, you need to work on this and practice this now, because if you can't get this, it's not going to be good for the test. All right. So we want to be okay at this, and a lot of the times, it's a little tedious, but like you literally have a map. Identify what's A. Well, how do I know what's A? Everyone, just try and do number 3 real quick. Tell me what is A and what is B. Just look at it real quick. Identify your substance A and substance B, and then literally follow the diagram. It'll tell you need the molar mass of substance A and the molar mass of substance B. Do that off on the side, and then you're just plopping in the numbers, multiplying and dividing, which I know you guys are all very, very capable of. Dude with the number.
On the test, if you give us one that we have to round, are you going to take points off if it's like 0.01 off?
No.
Okay.
No, absolutely not. If you left this one at like 1.976, you're good. So again, I see a couple of things here. I see calculate the mass of hydrogen gas that will be released with 3 grams of sodium reacting with water. So what is substance A? Dude with a number. Bet. Sodium is this guy, so I'm going to just put a little A above you. Thank you, bud. And now what's substance B? Is it water or is it hydrogen gas? Very good. It would be hydrogen gas. Because why? They said calculate the mass of that gas. It rhymes. Mass again? No? Okay. Anyway, that would be substance B. And where is that? H2 over here. So you need the molar mass of sodium, which is straight up from the periodic table. 22.99 grams per mole. And then H. Remember, it's a H2 in here. That is a common mistake. One of the diatomic molecules, guys, the Hofbrinkel group. Remember what Hofbrinkel, does anyone remember what Hofbrinkel stands for? These elements, when they're just said by their element name, they exist as diatomic molecules. Otherwise, they'd be chilling by themselves, all the other elements. So if they said, oh, you have, I don't know, you have gold, it's just going to be Au. If they said iron by itself, it's just Fe. Calcium by itself is just Ca. If it's one of these 7 dudes, Hofbrinkel. Sounds goofy, but it helps me memorize those 7 diatomic molecules. Yes, because it sounds goofy and it makes me laugh. And so when I see hydrogen gas, I know that that's got to be H2 when it's by itself. If it said oxygen gas, without even seeing the equation, I would know that it's got to be O subscript 2 by itself. So when doing the molar mass for this, you got to remember that you got to use that subscript. Hydrogen is 1.01 grams. There is 2 of them. So you're rocking with 2.02 grams per mole of the H2. Okay. So let's get it started.